Okay, welcome back. This is the 11th lesson of grade 11. Here we'll be studying about the midpoint theorem. You have the midpoint theorem and the converse of midpoint theorem. I'll give you the proof and then let us see how to solve questions related to that. Okay, the first part. Now here we will be studying about triangles. Okay, first now let me teach you what is this midpoint theorem. Okay, the first midpoint theorem. Say you have a triangle. Say you have a triangle. Let me name this as ABC. And say this is the midpoint. Let me say this PQ. These two are the midpoints. Therefore, I'll mark it this way. These two are equal. If I join P and Q. The theorem says that. Okay, it is like this. If you join the midpoint of, if you take any triangle, if you join the midpoint of one side with the midpoint of the other, okay, with a straight line segment, if you join it with a straight line segment, it is parallel to the third side. And also it is equal to half the length of the third side. Okay, so in statement, if I say the straight line segment, therefore this is equal to this, and also okay, let me write this. The straight line segment joining the midpoints of two sides of a triangle is parallel to the third side, and equal to half of its length. Therefore, if you join these two midpoints, you can say that PQ is parallel to BC and PQ is equal to half the length of BC. Is that clear? Now let me show you the proof. Okay. In order to prove the show you the proof, first you need the diagram. Therefore, let me draw this diagram first. Say you have a triangle. Let me name as A, B, C. I also say this is the midpoint. I'll name this as P. Therefore, these two are equal. And this side, the midpoint is Q. Okay, and these two are joined this way. Okay, and since this is the midpoint, these two are also equal. Now when you are going to prove something, first you need to write all the datas given. Okay, I'll make it short and write. Okay, the datas given are, you can say midpoint of AB is P and midpoint of AC is Q. Okay, you can say about the midpoints. You can write it down. Midpoints, you can say that P and Q. You can write it. The midpoint of AB is equal to P and the midpoint of AC is equal to Q. Okay, and then next you have to write what are you going to prove. To prove what you have to prove. Okay, you have to prove that PQ is parallel to BC and PQ is equal to half the length of BC. Okay, those are the two things we have to prove. Now there is a small construction. Okay, the construction is that I'm going to the construction is I'm going to draw a line through starting from C such that it is parallel to BP, like this. It is parallel to BP, and then this line joins PQ extended here. I'll call this as R. Okay, this is the construction. So you have to write drawing a line which is parallel to BP through C, and it meets PQ at R. Okay, PQ extended at R. So finally, since this is parallel, let me show it. These two are parallel. Okay, now shall we come to the proof part? Okay, let us prove. Okay, the proof. Okay, first you can consider ABQ triangle and QRC triangle and prove that they are congruent. Okay, in the two triangles, what are the two triangles? I said AP. Yeah, you can take APQ and QCR. Okay, now you have to prove the data given. You can say that AQ is equal to QC. What is the reason? AQ is equal to QC. That is the data given. Okay, and also you can say that, okay, you can speak about this angle and this angle. Both are vertical opposite angle, therefore those two are equal. Okay, you can say this angle is equal to this angle, therefore those two are equal. Should I need to write it? Yeah, anyways, okay. Let's say PQA, angle PQA is equal to RQC. You can say vertical opposite angle. Here you can say it is the data. Okay. Also the other angle I can take is that APQ, angle APQ is equal to CRQ. This angle is equal to CRQ. What is the reason? It is alternate angle. Since these two are parallel, if you draw a straight line across it, you can say these two are alternate angles. Okay, alternate. Now you can say therefore triangle APQ is congruent to triangle QCR. Now we have proved these two are congruous, therefore all the corresponding sides and angles are also equal. Therefore, since we have proved they are congruent, you can say now AP is equal to RC. AP is equal to RC. Okay, and PQ is also equal to QR. Since these are congruent, you can say their properties, their sides, angles also all are equal. Therefore, AP is equal to RC and PQ is equal to QR. Okay, is that done? Yes. However, you know that AP is equal to PB because this was the midpoint, therefore these two are equal. Therefore, since this is equal to this and also these two are equal, you can say PB is also equal to RC. Therefore, PB is equal to RC. Understood? We said these two are equal. We brought a relationship between these two. Therefore, this is equal to this. Okay. Now, since these two are already parallel, we drew a parallel line, and also this side is equal to this side now. Therefore, if you consider this quadrilateral, four sides, if one side is, if it is equal and parallel, you can say that it is a parallelogram. Therefore, BCRP is a parallelogram. Is that clear? Okay. Since it's a parallelogram, okay, therefore you can say that, therefore, PR is equal to BC. Why? If these, now we said these two are equal and parallel, therefore it's a parallelogram. Once we say it's a parallelogram, we can say PR and BC are both parallel and equal. Okay, therefore I'll say equal and they are also parallel. PR is parallel to BC. Is that done? Okay. Also you know that PQ is equal to QR, that we have already written here. Okay, PQ is equal to QR here. Okay, so since we have written, we can say that PQ is equal to half PR. Is that clear? since these two are equal, these are in 1:1 ratio, therefore PQ is equal to half the length of total length PR. Okay, that is equal to PQ is equal to half of, instead of PR I can write BC, that is equal to BC. Okay, now you have proved that these two are, this is half the length, and also you know these two are parallel. Okay, now you can say therefore PQ is parallel to BC and PQ is half the length of BC. Are you okay with this part? We have proved that it is equal to half the length of BC by taking this as a parallelogram, and since these two are equal, we said it is equal to half of BC. Okay, that clear? So already we proved that these two are parallel also. How? By considering this as a parallelogram. Since we said it's a parallelogram, we can say that PR is parallel to BC. Is that clear? Okay, the proving part is over. Next, we'll go to the question. We'll discuss the question on page number 27. That is based on midpoint theorem. This is the question given. You have to prove that Fs is parallel to TR. Okay, and the data is given. The line PS is the angle bisector of QPR. Therefore, this angle and this angle both are equal. And also the other data given are this PS is perpendicular to QR. Therefore, I have marked perpendicular. Also, they have said this F is the midpoint of QT. Therefore, I have marked these two lengths are equal. Okay. Now you have to, since you have to prove that Fs is parallel to TR, think now here you have few triangles given. Okay, you have a large triangle, inside there are two small triangles, and also there is a triangle on this side. Now, if you consider the triangles, okay, now you should think about the midpoint theorem. If you consider the midpoint theorem, now you know that if you join the two midpoints on either sides, on two sides of a triangle, if you join the two midpoints, forget about the length, there is a length relationship also, no? Forget about the length. Also you can say that these two are parallel, no? That is the theorem we have studied. Now if you need to prove that this is parallel to this, if you need to prove that Fs is parallel to TR, you have to use this triangle. Okay, somewhere at last you have to use this triangle and show that this is the midpoint of S is the midpoint of QR, and also F is the midpoint of QT. Therefore, if you join the midpoints, what can you say according to the theory? You can say that this is parallel, and also it is equal to half the length of TR. Okay, therefore, in order to prove, first let us prove that the triangles PQS and PRS are congruent. Okay, then you have to write sentence in the two triangles PQS and PRS. You have to prove congruency. How do you prove? Okay, one thing is that I can take I can consider this angle. Okay, these two are equal. Okay, QPSP angle QPS is equal to RPS. What is the reason? Angle bisector. Okay, mention those reason also. Angle bisector. Also, this angle is equal to this angle, since this is the since that is a perpendicular. That is the data given. Okay, therefore you can say QSP, angle QSP is equal to RSP. What is the reason? Perpendicular or data, whatever. Okay. Also, now you have said two angles and you have to consider one more side. Which side are you going to consider? You can consider that PS side is equal to PS. The reason is it is the common side. Is that clear? Therefore, you can say, therefore, triangle PQS is congruent to triangle PRS. What is the reason? Angle, side. Okay, now since you have proved these two triangles are equal, you can say that all the properties are same. Okay, that means now you have only proved three things. Okay, three datas, but you also can say that PQ is equal to PR, Also you can say this angle is equal to this angle. That is what you mean by congruency, right? Okay. Now using this data after proving congruency, I am going to say therefore QS is equal to RS. I am going to say that these two lengths are equal. Okay, I can say it. Why? Already I have proved congruency, therefore their corresponding sides and angles all should be same. Therefore you can say reason corresponding sides of congruent triangles. Okay, now you have proved this. Okay, now you have to write, let us say, consider the triangle. Now I am going to consider the triangle RQT, the smaller triangle. I told you you have to finally consider this triangle. Okay, now if I consider this triangle, okay, I told you that I have to show that S is the midpoint and F is the midpoint. Okay, how you can say that QS is equal to RS. What is the reason? I have proved. Or you can say it is the corresponding size of congruent triangle. Also, QF is equal to TF. What is the reason? That is data. Okay, you can say however that is equal because since it is the data. Now you have proved that this is the midpoint, this is the midpoint. Therefore, using the theorem, you can say using the midpoint theorem, you can say that Fs is parallel to TR. Is that clear? Because if you consider this triangle, this is the midpoint, this is the midpoint. If you join the two midpoints, this length is half the length of this, and also it is parallel to this. Is that clear? Okay. And then on page number, the next page, page number 28, the fourth question. The fifth one. Okay, they have given you a diagram. This is the diagram given. This is A, B, C, also Q, R. This is joined, and then you have P and S here. This is also joined. Okay, the data is given are Q is the midpoint of AB and R is the midpoint of AC, and also P is the midpoint of AQ and S is the midpoint of AR. Okay, you have to prove that you have to prove for PS is equal to BC. Where is PS? Okay, 4 times of PS is equal to BC. Okay, this looks very simple. Just you have to use the theorem only. Okay, first we'll say consider triangle AQR. If you consider this triangle, okay, you can write a statement that P and S are the midpoints of AQ and AR respectively. That is the data. Okay, now you have said that these two P and S are the midpoints. Okay, now you also know that if the midpoints are joined, you can say that it is half the length of QR. Is that clear? That is the midpoint theorem. It's simple, right? Therefore you can say, using midpoint theorem, you can say that PS is equal to half the length of QR. Okay, now I have to form a relationship between PS and BC. Now I have formed a relationship between PS and QR. Now what I am going to do is I am going to form a relationship between QR and BC so that I can replace BC here. Understood? Okay. Let me solve. To solve further, now consider triangle ABC, the larger triangle. Okay, you can say that AQ is equal to QB. It is same like saying that Q is the midpoint of AB, right? And AR is equal to RC. It is same like saying these two are the midpoints. Therefore, using midpoint theorem, you can write the same thing here also, okay? Using the midpoint theorem, you can say that QR is equal to half the length of BC. Okay, now shall I call this as 2 and then this as 1? Now what I am going to do is substitute 2 in 1. Therefore I have PS is equal to half. How much is QR? That is equal to half BC. If you multiply half and half, it will give you 104. If you bring 4 this side, that is equal to 4 PS is equal to BC. Is that clear? Okay, so this part is done. Okay, and then now, since we have solved all, we have done midpoint theorem, we'll go to what is converse of the midpoint theorem. Okay, converse, it is like bit opposite, not opposite, is the same thing, but you come from the back way. Okay, a converse of the midpoint theorem. Okay, that is okay. Now what about the midpoint theorem? Midpoint theorem, that is midpoint theorem. Since we have solved questions, you should be good in that. Say this is the midpoint, this is the midpoint. If you join the midpoints of two sides, okay, it is what? Yeah, half the length of the third side, or you can say, and it is also parallel to the third side. Is that clear? Yes. Now here what we are going to study is the converse of midpoint theorem. That is, if you take a triangle, let us name it ABC. Okay, say you have only one midpoint, let us say T. Now if you draw a line such that from a midpoint of one side, such that it is parallel to the third side, that means you are going to draw a line such that it is parallel to the third side, this side, it is going to bisect the third side. That means it is exactly going to meet the other side at the center. Is that clear? Here you are joining both the midpoints and saying that they are parallel. Here you join one midpoint and you draw a parallel line, and then finally you say it meets the third side at the midpoint. Is that clear? Yeah, this is the converse. Now let us solve one question based on this. Okay, let us move on to the 10th question on page number 10. Okay, the 10th question, that is on page number 10. How do you solve? Okay, 10th on page number 33. Okay, 33. Okay, they have given you a diagram. A triangle PQR is given. The data are the midpoints of the side PQ of the triangle PQR is T, and ST is the midpoint of PT. Yeah, T is the midpoint of PQ. Okay, this is the midpoint, and also the midpoint of PT is S. Okay, and also yeah, straight lines drawn through S and T drawn parallel to QR. Yeah, from this, if you draw a line parallel to QR, they are saying you parallel to QR meet the side PR at V and U respectively. Okay, so you are drawing a parallel line. This is also, let's say it's parallel. They are going to meet at V and U. Okay, is that clear? Okay. Now you have to prove two things here. First one is you have to prove that PV is equal to 104 PR. So where is PV? Yeah, PV is equal to 1/4 of PR. Okay, how do you prove? Now you can take, okay, since now you need a relationship between PV and PR. Okay, you can consider, okay, the triangle PTU. Okay, let us write a sentence. Consider triangle PTU. Okay, since S is the midpoint and SV is parallel to this side, the TU. Okay, since S is the midpoint, you have to write all this. Okay, S is the midpoint of PT, and SV is parallel to TU. Okay, since this is parallel to this, you can say that PV is equal to VU. These two, because it meets the other side at the midpoint. Therefore, these two lengths are equal. Since these two are equal, you can say PV is equal to half of PU. Okay, the same thing I'm going to use here. Now you have to prove that PV is 1/4 of PR. Now here what I have made, PV is equal to 1/2 of PU. Now what I'm going to do is I'm going to build a relationship between PU and yes, PU, and I'm going to bring PR there. Okay, now I'm going to consider triangle PQR. Now if I consider triangle PQR, I can say that T is the midpoint of PQ and this line is drawn parallel to the third side. Okay, yeah, it is said in the data, it is parallel. Okay, therefore you can say this line also, TU line also meets the third side at the midpoint. Is that clear? Okay, therefore I'll say also by considering triangle PQR, that is a larger triangle. Okay, you can say P is the midpoint, of, okay, T is the midpoint and TU is parallel to QR. Is that clear? PU is parallel to QR. Okay, therefore you can say PU is equal to UR. PU is equal to UR. PU is equal to UR. Since it is equal, you also can say PU is half the length of PR. Okay, now how do you build a relationship? Okay, how can you build a relationship here? Yes, here what you can do is, okay, instead of PU, you can, okay, yes, instead of PU, you know that PU is equal to half PR. Okay, therefore since you know PU is equal to half PR, you can bring that here. PU is equal to half PR, right? Yes. Therefore you can say PV is equal to half into, instead of PU I'll substitute half PR. That is going to give you 1/4 PR. Is that clear? It's about bringing two relationships and then you substitute. Is that clear? Okay. Okay, and the second part of this question, you have to determine the ratio of SV is to QR, which is SV. SV is the smaller length, SV is to QR. Okay, the same thing. Now since using midpoint theorem, you can say that SV is equal to half the length of TU. Okay, now write sentences like you used here. Considering this triangle, since this is the midpoint and it is parallel to the third side, you can say that this is using the converse of midpoint theorem, you can say that this length is equal to half the length of TU. Therefore, at first I will write SV is equal to half the length of TU. Okay. Also you can say that TU is equal to half the length of QR. By using the larger triangle, write sentences this way, and then you can say, using the converse of midpoint theorem, TU is equal to half the length of QR. Okay, TU is equal to half the length of QR. Okay. Now what should you do? Okay. Now let me write SV. You should know, you have to write the ratio between SV and QR. SV, you know, there is a value that is equal to half TU. Now for QR also you should write in terms of TU such that you can cancel off. Therefore QR is equal to, okay, this is equal to, QR is equal to, yeah, if you bring the 2 to the other side, 2 TU. Therefore here you can write 2 TU. Now what will have, sorry, this is not equal, it should be ratio. Okay, now we can cancel these two, and then finally you have half here, half is to 2. Therefore if you multiply both sides by half, by 2, then you will be getting 1 is to 4. Is that clear? Okay. Let us solve one more question. That is on page 32. Page 32, the 7th question. Okay. Here there is a diagram, a triangle given. PQR is the triangle, and then there is a line drawn. Yeah, they have marked this as the perpendicular. Also the midpoint. From here they have drawn a line such that these two are parallel, and also these two lines are equal, since this is the midpoint. Okay, this is L and you have N here, M here. Okay, if the length of MN, okay, find the length of MN based on the information given in the figure. If PQ is equal to 20 centimeters, this is equal to 20 centimeters. Now how do you find out? Okay, this total length is given as 20 centimeters. Okay, now what I am going to do is, okay, since this is equal to 20 centimeters, yeah, let me, what if I draw a line? Okay, I'm going to draw a line. Yeah, these two are also equal. Okay, these two lengths are also equal. Therefore L is the midpoint of QR. Now I'm going to draw a parallel from through L. I'm going to draw a parallel line to this QP or NM. Okay, I'm going to draw a parallel line this way. Okay. Okay, you can draw a parallel line. Now when you draw a parallel line, it comes to our normal theorem, converse of midpoint theorem. That is, if you consider which triangle, yeah, if you consider the total triangle, okay, the whole triangle, from this side, from the midpoint, if you draw a line such that it is parallel to the third side, it meets the other side at the center. Therefore these two lengths are equal. Okay, now using this triangle, you have to write the construction also. Okay, construct, I'll say here S, yeah, construct LS such that all that. Okay, and then using the triangle, the larger triangle PQR, using the triangle PQR, you can say that SL is equal to half the length of PQ. What is the reason? Using our converse of midpoint theorem. Okay, therefore what is the length of SL? SL is equal to half of this length, that is equal to 10 centimeters. Now what is the length you actually need? You need the length of nm. Therefore now consider triangle, consider the triangle PLR, the smaller triangle on this side. Okay. Now if you consider this triangle, N is the midpoint of this side, right? From this midpoint, this NM line is drawn parallel to LS. Now use our converse of midpoint theorem. From one side, from one midpoint, if you draw a line parallel to the third side, you can say that it also meets the other side at the center at the midpoint, and also this length is equal to half the length of the other side. Okay, this is the triangle we are considering. Sorry, you have to consider not PLR, you have to consider PLS. Okay, PLS. I'll draw it in red color. This is the triangle. Okay, if you have this triangle, you are going to draw a parallel line from one midpoint to the other side. It should be parallel to the third side, therefore it meets the other side at the midpoint, and also it is equal to half the length of this. Therefore you can say NM is equal to half the length of SL or LS. Okay, now since you know the length of SL or LS, you can say that NM is equal to half of how much is SL, that is equal to 10 centimeters. Therefore NM is equal to 5 centimeters. Is that clear? The questions are not hard. Okay, you just have to use the theorem and then prove. Okay, and then for more questions, subscribe our channel. Thank you.